In this video, we will look at how to find the pH of a buffered solution. If we look at the equation for a weak acid reacting with water, we can write the Ka expression. What we're going to do is rearrange this to solve for hydronium ion. That's going to be Ka times the concentration of the acid over the concentration of the base. We can also write this, if we want to, as Ka as the moles of acid over the moles of base. We can do this because concentration is moles per liter, and since it's in the same container, the liters are the same, so you can write it either as concentrations or as moles. It doesn't matter. This is frequently rewritten again by taking the log of both sides. So the log of H3O plus is pH equals pKa plus the log, base 10, of the concentration of A minus over HA. This is called the Henderson-Hasselbalch equation. Okay, bit of a mouthful, but the second version of the equation, that's a H, sorry, is properly called the Henderson-Hasselbalch equation, but this equation is the same. This first one is just a simpler version. It's the one I'm generally going to use. I just find it easier to use. You can use whichever version you want to. It's entirely up to you. So let's look at a couple of questions here. So I have an example. A buffered solution contains 0.5 molar acetic acid. So there's my weak acid. And 0.5 molar sodium acetate. So that's my weak base. So when I have a weak acid and its conjugate weak base, I have a buffer. So all I have to do is fill in my Henderson-Hasselbalch equation. H plus is Ka times the concentration of the acid over the base. So that's obviously 1.8 times 10 to the minus 5 molar H plus. Take the minus the log of that, and you get your pH is 4.74. If we want to do a second problem using moles instead of molarity, again, I've got a weak acid and its conjugate weak base. So I just go ahead and fill into my Henderson-Hasselbalch equation. Okay, my Ka, and then the moles of the acid. Remember, it's okay to use moles. I could change it to molarity if I want to, but it's kind of a waste of time. So moles, that's going to be 3.45 times 10 to the minus 4 molar H plus. Take minus the log of that, and you get pH is 3.46. So finding the pH of a buffered solution once you identify it is pretty straightforward.